Hello students, let's start the class. So in the previous class we tried to revise and see about the introduction of the machine learning. So we try to see that what is machine learning, and then when we use the machine learning and the type of the machine learning, and like that one. And also we try to revise about the application of machine learning in different areas and tasks. Next to that one, we try to start about the machine learning types for different problems. Today we will try to see in detail about the different machine learning types. So in the previous class, actually, I tried to mention about how to just define the type of the machine learning algorithms. So in order to select our machine learning algorithm, there are some steps that we need to do, before deciding the machine learning algorithm from that one. For example, the first one is we need to define the problems or our problems. So let's say, for example, before selecting the machine learning algorithm, we should identify what type of problem I need to solve by using that algorithm. And then the next step is just like creating that data set from that problem. And then based on that data set, we need to decide that which type of machine learning types can be selected. Because in order to select that algorithm, the data has an effect in order to select the appropriate machine learning algorithm. So this is some of the steps. So based on this data nature, so we try to see that there are different algorithms. So for example, if our data type or based on the data natures, the algorithm is like categorized like supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learnings. So it depends on our problem and our data natures. Maybe we can just try to select one of the algorithm from this one, and we try to solve our problems. So the next step is we try to see about in detail about each type of the algorithm. So the first one is about supervised learning. So in the previous class, we tried to see about in general what is supervised learning. So in order to highlight that, or in order to revise about supervised learning, when we say that supervised learning is the type of learning that the data nature should be labeled data, or the data and the corresponding labels should be given. That means if our data nature is labeling data, that means we should have the input, futures, and the target labels. That means like this one, given x1 and y1, x2 and y2, x1. So the data processing of in the supervised learning should be looks like this one. So for example, when we say that in the supervised learning, like the data should be prepared like this one. This, let's say, just like table. So we should be categorized like this one. So let's say, for example, x1 here, x2 here, and then we have the y. So x1 and x2 is this type of, like, for example, there's a type of that used to represent the input futures, and y is represent the targets. So in this x and y, in this and xy, this is the table. For example, this one and the house size and room size is a type of input futures, and price is the expected output, or that is called the outputs or the targets that we need to predict by using the model. So that means x1 and x2 is an input futures, and y is the expected outputs or the targets. That is called the data labeling. So always in the data pre-processing part, the data should be prepared like that one. So before we use the algorithm, or before we select the algorithm, our data should be like this one. That means like we need to know that the x part, like maybe this one actually not only one, maybe it's like the number of the future is maybe more than 2. So maybe x1, x2, x3, x4, x5 is like maybe up to 10, or like more than that one. And then also the output results is like maybe 1 or also 2. So but based on this data, the purpose of this one is just by using this type of data like the house size and room size. If we know the house size and room size, then our goal is just to predict the price of the house. So that means as an input we use these two attributes, house size and room size, and based on these attributes we need to predict the price of the house. So that means the data should be processed like that one. For each x1, this x1 means this one, there is a value of y1, that means this one. For x2, this one, x2, for this one also, there is also the value for that one, each combination for this one. So the data should be labeled like the x and y. That is called unlabeled data. Or that is, so y is represent the ground truth. That means the expected output from that data. And from this one, actually, M represent the number of the training sample. So this represent the number of the training sample. That means maybe we have 10 data or 15 data, 100 data, more than that data. So this one is represent. If we have like 1,000 data, that means until x 1,000 and y 1,000 data. That is called supervised learning. So this type of that means when we have a data that we know that the input attributes, and if we know already the target attributes, that means we can say that this type of problem is a supervised algorithm, and we should select the type of supervised algorithms. This is an example. So in order to develop the model in the supervised learning, the first one is we should be prepared the training set. That means the data. So a training set is like the data set. That means, for example, from the this one, let's say, for example, this is a data set or a training data set. That is our data. For example, we need to collect some data by using the experiment or the simulation, and then we need to make it ready, that data, for training our model. And then after that one, we have a training set, then we should select learning algorithms. So if our training data have a labeled data, that means that our algorithm is like we should select from supervised learning. So there are different algorithms in supervised learning. Actually, we will see also this part in detail. And then we select the learning algorithm from here. And then here in the learning algorithm, we try to train the model by using the data and by adjusting different parameters. And finally, we have a well-trained model. That means after training that model by adjusting different parameters, finally we have a model that is well-trained and well understand about that data, and it's ready to predict the price of the house. So in the training set, it have the information about, let's say, for example, from the previous data, the house size, the room size, and also the corresponding of the house of the price. Then if once the model is well trained, we can give a new test data or unseen test data. A new test data means a data that is not included in the test data, in the training data. So the test data is different from the training data. What is like in the test data, we only give like the house size and room number, but not on the price. When we input this one, the model is like based on this information and based on actually the previous learning from this data, then the model automatically predict the price of the house based on the house size and the room numbers. And then the model starts to predict or estimate the house price for this room size and house number and room numbers. Then we can get the estimated house price. That means after this one, just we need to give only the house size and room numbers, and then the model is automatically predict and estimate the house prices based on the training information. So this is the way the supervised learning algorithms. This is the sample data, that how we label the supervised learning algorithms. For example, in the supervised learning algorithm, we say that there is a corresponding of x and y. So x represent the input features, and y represent the targets or the ground truth. So that means when we input this X value, the output is like the cat. When we give this one is as an input feature, X2, that means the model understand that, or we can give also, we can say that this one is a dog. That means the model have an information both for this image and also the target or the ground truth of this image. Then we train the model by using this one. So the data is labeled by this one, X and Y, and all this data is fed into the algorithm. So this actually, for example, this indicated that maybe like our data is like too much. So we can just list all the data in different ways. This is also another way, like for example, in order to predict the type of whether it's car or bike, we have different car types here. So also we can define or label also the type of whether this one is a car or a bike. So our data nature should be include also this X and Y. This represent X, which indicates the car and the bike image, and the Y value represents like the name of this one. This is car, this one is car, this is a bike, this one is a bike. So the data, this one is means also the corresponding of X and Y. X represents the car and Y represents the expected output. So in supervised learning, we need something called a leveling training data set. So the data set, only training data set, should be arranged like this one. That means the model has understanding about the relationship between the input attributes and the input images, and then the expected output for each image. Then next time when we give some image, he can compare and contrast like based on these trainings, and then automatically classify like a car or bike. Let's see this example. So given a label data set, this is a label data set. The task is to devise a function. We take the data set. This is just a data set or the total training data set. A new sample and produce an output value. Then now we train the model using this training data set, and then we need to test our model whether it's well trained to predict a new data set. So for example, this is the let's say a function or a model in the framework. We say that in the model, let's say we say that y is equal to f of x. So this y is represent the output, and f represent the function like this one, and x is represent like some figure. So from this one, let's say for example, you see here, so based on this one, y is equal to f of x. So y is the output, and f is represent the function of this one, and x represents from this one, x represents this car. So from this one, for this one, y is equal to, based on this one, the output is equal to car, y is equal to car. So this is the way how to define the models. So that means this is actually is different from these pictures, but the model is automatically understand if this one is a car or a bike, because this is more similar with this one. The model classify this one as the car. This is the way how the supervised learning can train, by using the labeled data set. So in the supervised learning, predefined class means it will produce outputs only from the label defined in the data set. So that means, for example, in this case, we have a data feature here and the label here. That means the output value, the produced output only from the label defined in the data set. So the output is maybe either car or bike in this case, because we already defined the labels. So we didn't get any outputs that different from this one. If we put the label here, car and bike, that means the expected output, or the output of this one should be either car or either the bike. For example, even if we input a bus, it will produce either car or bike. For example, in this case, we input a bus, but we didn't get the output bus, because here the label is only car and bike. So if we need to label for each bus, first we should be include here every pictures, and then we should be labeling here like a bus and the other attributes. Either if we include here and the label is here, that means the expected output is only from the label data set. So this is the nature of the supervised learning. This supervised learning is used for two types of problems. So commonly, actually, supervised learning is the most common type of the algorithms that is used for mainly for two types of problems. The first one is for classification. So when you say that classification, the output value is discrete or categorical. So that means they predict which classes a given sample of data or sample of descriptive features is a part of a discrete value. So in classification, the supervised learning is used to classify the data. That the data nature is discrete or categorical. So discrete means we can say that just only discrete. Let's say, for example, the value of the data is either maybe 0 or 1. This type of output value is maybe discrete. Or we can say that the output value may be M or F. Just say, so when we say that a discrete, like the value is well known or only just a specific number. Or categorical means is a category like this one. Or maybe just the category is between, maybe just like we can say that the value is or the category is maybe in the, let's say, from 1, 2, and 3. Between this category, we can say like this one. So this is the way that we need to define, how to define these supervised learnings. That is called, so categorical. Let's say, for example, if we want to classify the emails like spam or not spam, that is called categorical. So the email is either spam or not spam. So the only option is like two outputs. That's called categoricals. Or maybe, for example, let's say that in the classification of, like, for example, in the animals, let's say maybe there is different category in them. Is that dog or cat? Is that like this type of? In the car, for example, in the car example, it's categorical, whether it is bus or whether it's car or whether it's bike. So categorize like this one. And that is called a classification. The other one, for the other problem, is the second one is regression. When you say that regression, the output value is continuous. So we cannot determine by specific numbers when we say that regression. When you say that regression, the output value is like maybe is not specific, is type of continuous. For example, based on this one, this just regression examples as shown here, the value is like a continuous. In this point is different, in this point is different, so it's like vary. We cannot specifically assign one number. Let's say, for example, in order to predict the traffic for the next period. So maybe the traffic value is like the predict the traffic for the next period is like we cannot determine on that one. Maybe in the morning is different, in the middle of the day is different, in the night is different. Let's say, for example, also in order to predict the temperature. The temperature value is like we cannot determine just only one specific value. It varies from time to time. So let's say, for example, in the morning, the temperature value is like 23 degrees centigrade, and then maybe 24 and 29 and 35, like this one. So there is no specific value. So the value maybe is like changing through time. That is called is like a type of the problem is continuous. So the temperature is like this one. And also in the predict the traffic value, the value is always vary. It depends on maybe different factors. That is the way it's called regression. So for this type of problems, so this supervised learning is more important in order to solve this type of problems. The other one, this actually, for example, the left figure, it showed that the classification. For example, there is a text here, so that's defined for this one, for example, and then this text is classified as class A and class B. That's for the classification. So there are different algorithms for classification and also regression. So we will see this one also, like after the just revise about what supervised learning and supervised and the other algorithms. So this is just the highlight that showed that the difference between regression and the classification. I think we already mentioned this one. When we say that regression, the task of predicting a continuous quantity known as regression. Whereas a classification process involves anticipating a discrete classical level. So that is just discrete. We know that already the outputs, maybe either 1 or 0, or maybe male or female, like this type of the output that is called a classification. So in regression, the task is map actually both have input x and the expected output y. Also here, the map is x and discrete output value y. So this is the way that in order to represent or classify the regression and the classification. So in regression model can predict a discrete value, but only in the form of an integer quantity, whereas in classification model can predict a continuous value, but it is in the form of probability for a class level. So in regression, when we predict, for example, in order to predict the temperature, we just say that the temperature is either 25, 26, or 37. Just the prediction is a discrete value. That is quite, here is say that discrete value. But in the classification is a probability. The probability is maybe either 0 or 1. So there is a probability of 2 options. So that is the way the output value, and this is just the difference between the two. So when we say that an example of the classifier, this is the data set. In the data set, there are different type of animals here. The one is elephant and the one is tiger. So this data set is input into the classifier algorithms. And then we train that based on this data, the algorithm is trained. And finally, in order to test this model, whether it's clearly classify different animals, we give, for example, this animal as a test for this classifier. So giving this animal to the classifier, and we can say that identify the animal, and then it said that the model said that this one is elephant. So classifier is working like this one. Also, we can just input some animal here and give into the classifier, and the classifier is try to predict the name of the animal. But the name of this animal is depends on the labeling of the data and also the training data. This is also the supervised learning for classification tasks, an example for a training set and the testing set. So this showed that the general structure of how supervised learning looks like, that one for classification. For example, the first step, let's say we have a training data set here. So this training data set that have different features or attributes here, and also there is a class or a label that's called this y. So in this one, it represents this like this one is x1, x2, x3, and x4, and this one is represent the y. So all these x values indicating like for input attributes, and the class y is for the target outputs. That means when the attribute value, like this is id actually, maybe it's not more important, but the attribute 1 is when it's yes, attribute 2 like when it's large, and the attribute 3 when it's the value is 1 to 5k, that means the class is categorized as no. When the attribute is no, when the attribute 2 is medium, and the attribute 3, let's say 100k, the class is still no. Like so, we should be define the data nature like this one. When the attribute is no, and when the attribute 2 is large, and when the attribute 3 is 95k, the class is, we say that yes. So this is just a sample data, and we label the data like this one. So this is called supervised learning. That is the learning. This part, the attribute part, is like the input features, and class is like the ground truth, or the label class, or the class of the label. This represent like that one. So this training data is feed into the learning models, or just for the entrain the learning algorithms, and we have we train the models, and then finally we have a model here. That means by using this data, train the model here, or learn the model is learned by this data and understand the relationship between the attributes and the final outputs. And that means finally we have a trained model. That trained model means actually he's ready to predict. When we give the test data, is automatically predict the class. Then we try to apply these models, and we need to try to test the model by giving only the attribute value. You see, this one is a test data. So we say that our model is already trained by using this data set, and it's ready to predict the class. So in this test data, the same structure with the above data, or from the training data set, but the only difference is in this test data we don't know the class. In this case, in the training data set, we know the class also, but in this case we don't know the class. So the class is, for the test data, the classes should be predicted by the model. So we don't need to identify the class by ourselves. This task is done by the model. That means when we give this one, this data, just check every step on this one, and then based on the learning from this data, the model is predict the class of this one, the class of this one, the class of this one, and the class of this one, and the class of this one. That is test data. So the test data is indicating that whether the model is predict the test data based on that training sets. This is the way of the supervised learning. Also, this is an example, like it's related to the optical communications. For example, this result showed that the algorithm is trained on the data set that consists of the path, wavelength modulation, and the corresponding bit error rate. Actually, this diagram showed that the routing finding, which one is the shortest path to move from the signal from one place into another one. This is actually the network, or like this one. There is different ways, like from this node to this node, or in order to move to this one. So it's a type of, actually this is the network, that different routers here, or different remote nodes here. So in order to move from this to, let's say for example, the final destination is E or F, there is different possible paths or ways to move to this one. So the objective of this algorithm is just in order to identify which path is the most efficient one based on the performance. So the algorithm is trained on the data set. Our data set consists of the paths. For example, in the training phase, have a wavelengths, have a path like A, C, D, G, F, means A, C, D, G, F, this way. This is the path to move to this one. And we know the modulation one is QPSK, and the bit error rate for this path is 10 to the power of -5. When the wavelength is 1553, and the path is based on B, D, B, G, D, F, E, B, G, D, and F, E. There is also this way. So when the modulation is QPSK, the bit error rate 10 to the power of -2. And then finally, we need to test the performance when the path is, or the wavelength is this one. The node is ACDGF, ACDGF, and then the modulation is QPSK. So we need to know also the performance, or the bit error rate performance. In the optical communication system, actually the different paths have different performance or efficiency. So like bit error rate is the one performance measures in optical communication that indicated that whether the communication system is good or not. So this bit error rate performance, this one is 10 to the power of -5, for example. It showed that like, and 10 to the power of -2 also like indicate that the bit error rate performance. So when they compare on this one, so based on this training data, also the algorithm try to predict the better performance of this paths. So this is the data nature of supervised learning. So we need to know first we should be give for the model the different attributes and also the expected outputs or the ground truth, and we train based on that one. Finally, we can test that only by giving the input features, and then the model try to predict the ground truth. This is a supervised learning. When you say regression, for example, the one example in regression, this is an example. The data set is that the size of the home and the room number. Like for example here, when the home size is like increasing, it's expected that the price is also increasing. So if the possible output values of the function are continuous real values, then it is called regression, because it's continuous actually. The value is like always, it depends on the house size and the room number, and the price is like increasing. So in order to predict that one, for example, this is the model, f of this house, and then the model is automatically predict the price of for this house. And then we can give f of then another house, and then it predicts the price of the house that depends on the size of the home and room number. This is regression. When we say the regression, just the output value is only one value, because just only is not categorical, just the output value is like one real value. This is called regression. So for our data nature, if our data nature is a type of a data, it should be labeled data. That means we need to select a type of supervised algorithms. But then after just selecting the supervised learning, and then also we can decide that whether that's for classification or regression, also another step. So first we should be defined that our problem is like for classification or for regression, and then we can select the type of the algorithm which is fit for our problems. That's called supervised learning. Example of supervised learning is like for speech and image recognition, also implemented for a spam classifier, for house price prediction estimation. This also actually not only this one, there are other applications, just this is the sample one. So you can try to just read more, and you can see that different supervised algorithm for different tasks or examples. So this is just the sample one. When it comes to unsupervised learning, the difference from supervised learning is in unsupervised learning only input data and X is given, but no corresponding output. That is the difference from supervised learning. In this case, supervised learning is equal to X and Y. The representation is like this one. But in unsupervised learning, the representation is only X. No need to define the Y. If this type of data, if the data nature is only we know that the X value, but we don't know about the Y value, that means we should know, or we should use the unsupervised learning. That is the difference from the supervised learning. So discover patterns which is unlabeled data. So no explicit output data is provided to guide here. So the machine try to find its own way to learn the mapping function between that data. Based on the input data, it just try to map the relation and then finding the output values. So the data nature is, or the data is preprocessed or given only x1, x2 and until xn without labels. So only x data. In supervised learning, we know that the expected output also, but in unsupervised learning, we don't know the expected outputs. Just we have the input features, but we don't know about the expected outputs or the ground truth. That's called unsupervised learning. So this is just like, for example, this picture, it showed that the input value, we know the input value, x value, and the function actually unknown, because still we can select different type of unsupervised learnings, and the output value is unknown. That is, the y value is unknown here in supervised learning. But when we come in supervised learning, this one is known and the y value is known, But in unsupervised learning, X is known, but Y is unknown. So in this type of cases, the machine tries to identify the underlying characteristics present among input samples as its outputs. So look for hidden patterns and relations in the data, just only by identifying or looking hidden patterns and relations from the data, and then predict the output values. So based on this one, if our data nature is unlabeled data, that means if our data is only known by the input features, but we don't know about, or we don't have any information about the expected outputs, in this type of cases we should be select unsupervised learning. This is an example. That's, for example, in unsupervised learning, the most type of problem that we try to solve is like for clustering. Cluster is like, for example, here, cluster similar data points. So in this way, is we have unlabeled data, that is different shapes. We don't know about this shape actually. So this shape is already like, this is the data nature, but the shape name of each one is not defined. So this shape is just train the machine or give or input into the machine, and finally just the model try to classify or cluster similar shapes into one, and like based on the similarity he tried to similar, like this group this one in one cluster, group this one in one cluster, and group this one cluster. So by using hidden patterns and features, try to cluster similar data together and similar data together and similar data into together. So just we give this different shapes for the machine, and the machine he try to just clustering the data based on the similarities. So if our data nature is just only this type of data, we try to use the clustering, unsupervised learning. So in the unsupervised learning, the main objective is like derive structure or patterns from the available data. So derive structure and patterns from the data. Clustering, finding groups of similar data. So from the data nature, when we give some data, just group based on a similarity on the data. That is the one, an example. So let's say an example on the cell traffic classification. Understand if someone cells provide similar patterns, or like classify, or cluster the peoples based on residential, business, close to theater, cinema, stadiums, like this one. So just we can cluster the peoples that have, like for example, based on the status of the education, based on, for example, like based on like the income, or based on the residential information, or based on the businesses, we can cluster into similar groups. Let's say group the peoples according to their interest to improve advertisements. So we can just, for example, we can collect the data from the people based on like the advertisements. So we can group based on the interests. We can classify, like for example, some people may like music, some people may like movie, some people may be like playing the other things. So based on that interest, we can just cluster into different groups. That is the way for clustering or unsupervised learning. So this is the way the data set, how to label the data set in the unsupervised learning. For example, this is the way. We need to only define like this type of figures. No need to define here. In the previous one, in supervised learning, we should be mentioned both this one and this one, but in unsupervised learning, only X value is needed, but Y is not necessary. That is why. So only the input feature is necessary, but the label, the Y, is not necessary. In unsupervised learning, we don't need to know the labels or the ground truth values. That is why we don't know this one. We don't need to use this one. Only input this feature for the algorithm, and the algorithm just cluster based on the similarity. That is the basic difference for this one, because this is why we need to, this one is in some data natures, we only know that the input features, so we don't know about the outputs or the expected outputs. So because of that one, we don't know about the labels, so at that time we should be select the type of algorithm which is called unsupervised learning. So the typical example in unsupervised learning is like clustering. So we say that, for example, this is the data that have different attributes, like for example this one is about the flowers. So this is the attributes about the iris flower. So there is spatial length, spatial width, petal length, petal width, have these informations. So based on this information, just clustering some groups here and some groups here, and there is 3 different clusters. So most common or similar data is grouped like in this one, and the other is in this one and this one. So the algorithm or the model try to clustering based on the similarity. So when we give this one, in this case, no classes, just we give like the data, and finally we get the outputs or clustering. This one also like clustering, just cluster based on similarity with different groups. That is called unsupervised learning. You see here, this one is the data set, just only the data set, and then the model can cluster the data based on similarity. So just this one and this one is more similar, that is why it's clustering in one group, and the 2 picture is like similar and clustering for this one into one group based on what? Based on similarities. So the task is to identify the patterns, like group the similar objects together. The same thing here. There is a different peoples here. So have a class. So based on the similarity, just categorize into different groups, just based on similarity. So unsupervised learning is just more focused on the just like based on a similarity. The same thing for this one is actually more related on the previous, that the algorithm identifies unusual patterns in the data. Like for example, this one is also similar with for anomaly detection. So unsupervised learning also is mostly important for anomaly detection, in order to identify in which area or whether that data has anomaly or no. This is the one application for anomaly detection. Mostly or commonly we use unsupervised learning. For example, from this figure it showed that actually like this is also the network in optical communication. We say that for example the network that have different paths for transmission the signal. So this already we know that the data, we know that the wavelengths, the paths, the bit error rate, and the modulation. So based on this one, like for example, we have a data. The data showed that have the wavelengths, like this one for example, have a wavelength here, and the paths also, the nodes from A, then D, A, B, D, E, like that one, A, B, D, like for example, move to A. And the modulation is QPSK, the bit error rate becomes 10 to the power of -6. So when we use this path, A, B, D, E, the bit error performance is 10 to the power of -6. When the wavelength is 1545 and the path is from B, D, and G, and F and E, then the modulation is changed into 60 qua, the bit error rate achieves 10 to the power of -7. So we try to just collect a different data by changing the attributes, like by changing the wavelengths, by changing the paths, and then the modulation. The output is actually we need also the bit error rate performance, because the bit error rate performance is actually the measurement to decide that which one is actually the best performance. And then the other one, for example, here is a breakdown. The fiber is break here. So in this path, when the wavelength is here, there is a path ACDGF. ACDGF, that means have a breakdown here. So the bit error performance becomes 10 to the power of -2, which is like a poor performance. Because of what? Because of there is anomaly here in between the link of C and D. So this is just, that means if the bit error performance is become small, that means there is some error there. That is, so in order to detect which paths have a problem or which paths have a best performance, we can use also this type of similarity or categorization. And also here, so this just clustering the best performance here. This one is the green one, is it shows that the one that achieved the best performance, that 10 to the power of -6 and 10 to the power of -7, which is a good performance. And because of also these paths have a anomaly detection or a link failure here, just clustering into one group, which is the better performance is below 10 to the power of -2 and like that one. So for anomaly detection, let's say for example, for different things we can apply that one. So in order to identify whether that have a problem or anomaly or not, in order to identify this type of data, we can use also anomaly detection. So when we come to in the optical communication, maybe there is different anomalies because of maybe like environmental factors or maybe device failure or maybe fiber break. So these all problems maybe happen. So in order to easily identify this type of problems, we can use like unsupervised learning. Unsupervised learning also like is important for this type of product. For recommendation also. Like for example, someone is buy this one and then just recommend for customers who viewed this item also viewed this one just for suggestion. So for this purpose also is important for that one. So this is just a type of example that shows the difference between this one, how supervised learning and unsupervised learning looks like this one. For example, this is a type of supervised learning and this is a type of unsupervised learning. So in supervised learning, we say that the data should be a type of labeled data. That means if we have this image, we should have also the labeling or this one or the name of each animals. So for each image, we should give also the name of that image that's called X and Y. But in unsupervised learning, we know only this image, but no need to define the Y value or the name of each one. So in this one, just automatically just classify. When we give some image, then the algorithm say that, for example, when we give this image, the algorithm say that, or this one is the cat. When we give this image, the algorithm say that, for example, this one is the dog. But when it comes to in the unsupervised learning, not specifically predict the name of the animal. Instead, he try to group similar animals together and then similar animals together, not to try to specifically identify the name of the animal. So you see, here just only try to clustering or grouping similar animals together, similar animals here and similar animals here. No need to define specific the name of the animals like this one. This is the basic difference. So if our target is just grouping or just clustering the data, similar data together, we can select unsupervised learning. Or if our goal is just try to indicate that or identify that what specific outputs, we can say that or we can pick that type of supervised learning. That is why it depends on the nature of the data. So depends on our goal, we can select a supervised learning and unsupervised learning. This is the main contribution. The third type of algorithm is like based on the data nature is a type of semi-supervised learning. Semi-supervised learning is a type of learning which involves like combination of labeled data and unlabeled data. So where a large amount of input data is available, but only some of the input data is labeled. So in this case, in semi-supervised data, some of the data is labeled, but the majority of the data is unlabeled data. So the main objective is most of the training samples are unlabeled, only few are labeled. So because of sometimes actually common when labeled data are scarce or expensive. In some cases, maybe it's very difficult to get like labeled data. So we only need to label some data, then their data just like learn from that labeling data. So this type of case is called semi-supervised learning. So self-training data. That means in this case, start with label data and then the label and labeled data based on first phase. So the unlabeled data is learning based on the few labeled data. That means, for example, we have some data. Some data is like, we say that x1, y1, x2, y2, x3, y3. We have this type of data. And then some of the one is x4, x5, x6, x7, x8, x9, like that one. So some of the data is labeled data, but the majority of the data is not labeled data. That means this type of data is learning from this labeled data. So this type of parameter is important, especially when labeling the data is more scarce or expensive. So we'll try to teach the algorithm based on some labeled data. That is the way. So in this case, for example, the input is known, the output still is unknown, but the output is actually, because some is known and some is unknown, that is, some of the data is labeled, but some of the data is unlabeled. That is why here it showed that an output data is a combination of known data and unknown data. That is called semi-supervised. Some of is supervised and some is unsupervised. That is a combination of supervised and unsupervised learning. This is an example that showed that the semi-supervised and algorithms. For example, some of the data, this input data, is the majority of the data is unlabeled. Just only put the fruits here. So we didn't define that the name of this one, the name of this one, the name of this one. But here there is some data that is labeled. So in this case, we labeled that this one is orange, this one is banana. That means this one is just understand that based on this labeling, the model also try to label based on that one, and then we feed this data into the machine learning algorithm. And then when you give a new data for a test, like this is unlabeled data, only give this input. So because know that this one is orange, this one is banana, that means when we input this one, he understand that it is an apple. That try to also generate a new labeling based on the other data. That is the way of semi-supervised. Some of the data is labeling, some of the data is unlabeled. But so by combining this one, just when we give a new data, the prediction is coming or classification is coming. The fourth one is the fourth type of algorithm that we need to consider is like reinforcement learning. So reinforcement learning is recently also is like the one of the hot topic that is try to solve especially for gaming is the one algorithm. And also in addition with that one, actually it is like the type of the algorithm that involves training a machine agent to perform actions within a virtual environment to achieve a certain goal. So this type of reinforcement learning is available data is not labeled, this one also, but the way the training is different from unsupervised learning. It's like the data in this case is also not labeled. So the main objective is just learn a policy that is mapping between input, states, and the actions. So in the supervised learning, we need to define, or we need to know that the input or the states, the actions, and the rewards. These three things is the common one in order to just define for the reinforcement learnings. For example, if we train a machine to play a chess, the chessboard is the environment and the machine is the agent. So based on that one, when we play in the chessboard, if we win the chessboard, that is, we can get a reward. Either if we lose it, we can get the punishment. So the relationship between is like this one. In reinforcement learning is mostly common is type of reward and the type of the punishment one. So this is the way that really showed that determine. So the agent movement determine the possible actions that the agent can take at any given stage. For example, this is the structure that showed that the reinforcement learning. So there is an environment here, and there is an agent here, and then there is between this agent and the environment. So there is possible status between the environment and the agent. So the agent, he tries to see that the possible status here in the environment. And then based on the possible status, the agent tries to take actions in the environment. And then finally the agent can get a reward from the environment. This is the relationship. So the agent selects the best actions based on the environment state. So there are different actions. For example, in the chess game, let's say, there is different actions, or the movement maybe is like try to go in the left, try to go in the down, into right, and up or down, these possible actions. So when you go in the up, maybe if he is a winner, then there is a reward. So the possible state is just the type of the actions or possible actions. That means up, right, left, or maybe down, like this type of actions, for instance. And then when you take like just one action, that means either go up or move, down, or right or down, then when take that action, there is a reward. That is the way. So the agent selects the best actions based on the environment state and receive reward or penalties based on its choice. That is the way. So here there is possible states, and then take one action from that state, and then based on that action, it receives rewards or penalties. This is the relationship. So the algorithm aims to maximize the reward and minimize the penalties. So our goal is try to maximize the rewards and making the possible moves. So the agent learns to improve its performance through repeated iterations with the environment. That is called mostly reinforcement learning, is a type of try and error, like try. When we try more and more, we can get or we can learn more. That is a type of try and error type of learnings. So just this is like a pseudo algorithm that show that, for example, the agent and environment interact at discrete time steps like this one. There is between the environment and the agent. Agent observes a status at step t or time. So there is let's say there are different statuses, and then produce actions based from that possible status. Just select one action and get its resulting reward, or resulting next step is like just continue to the next step. This is a type of reinforcement learning. For example, this one, an example that showed that about reinforcement learning example. So the agent is the baby and the environment is the mother. So the mother just try to show that the task, different task. For example, this one is the milk, or this one is just the glass. So if the baby get this one, that means reward. If get this one, that is a punishment, for example, on the learning process. So that means if the baby already get this one, that means there is a punishment. So when the baby just do wrong things, the mother try to give this one. If the baby just do any good things, that means the mother try to give this one, which is a reward, but this one is a punishment. Then in the next time, the baby can understand that if just try to do the good things in order to get a reward or in order to get this milk. This is the way just learn the baby how to just perform the good actions or things. So the baby learn from the trial and the errors. So he just understand that, and the next time maybe he try to just in order to get this reward, he try to make it like or understand that what type of actions he can do in order to get this milk. So the reward is just if the baby learns from the trial and errors in order to get this milk, and the mother give that one. This is the way reinforcement learning the one. Another example of reinforcement learning is training autonomous robots to navigate and perform tasks, controlling autonomous vehicles such as self-driving cars. Also, like just train that one. So when the car, for example, moving somewhere, just understand that the punishment and the reward, and optimizing energy consumption in smart homes. This all is an example of the reinforcement learning. This is also a type of reinforcement learning that showed that in the same cases in the optical communication scenarios. So the same like the previous one, but there is an agent in the environment. So the environment is just the optical communication, like the different routing paths. So the agent actually there is possible actions here. The action is actually, for example, just learn that initial state. We know that, for example, initially we can make it the wavelength is here. the node here or the possible path, the modulation is QPSK, and the bit rate is the 10 to the power of minus 3. So the action is no change. That means the state or the 10 bit rate to the power of minus 3 reward is 0, because just this one is the initial state. Then when you change the output power, here for example originally there is also the node is similar with the initial, the modulation is QPSK, the bit rate is similar with the previous one, but we try to change the power. Then we try to make it the plus 5 dBm power, and then the state or the reward, or then the bit rate is become 10 to the power of minus 2. So the reward is minus 1, which is a punishment. In the next step, we try to change the modulation instead of the power. So the wavelength is the same, the path is the same, the modulation is, now we try to change only the modulation part. So when we change the modulation into BPSK, the bit rate performance becomes 10 to the power of minus 4, which is increasing from even the initial one. That means we get a reward plus 1 here, that is the reward. So from this data, the model or the machine understand that maybe changing the modulation is the better way in order to get the more better performance or a reward. Also understand that changing the output power is a punishment. So that means in the next step, no need to change the power, either it's better to change the modulations. So this is the way how the reinforcement learning that one, by changing different parameters, and then we try to see that what the punishment, how to the reward. Then next time the agent and the environment have a communication and they understand and learns about that one. So this is just we have from the initial one. When we change something, he try to compare and contrast from the initial one, from the initial or from the beginning one. And then if the next step is better than the initial, that means there is a reward. If there is a less performance than the previous or the initial one, that means there is a punishment. So based on that one, the model understands punishment and reward and take its actions for the next step. Okay, now we already see that different type of algorithms that we need to just consider in order to do different tasks. So we try to revise that there is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learnings. So each type of algorithms have its own just different properties. So also we try to see that actually the most common one is like recently like supervised and unsupervised, and then reinforcement learning is just more on the deep learning networks. So when you see that supervised learning most commonly used for the classification, regression, and also for recommender systems also, and unsupervised is for clustering, anomaly detection, and association rule analysis based on this one. And when it comes to in the semi-supervised, actually the combination of this supervised and unsupervised. And reinforcement learning is like our type of the data or the problem is like type of punishment and reward, and then based on that one, just no need to labeling actually, but just based on the actions and rewards, just try to understand about that one. So this is just the common thing is about the supervised and unsupervised one. So in the next PPT, we try to see in detail about the classification, regression, and about that one, because the majority of the common majority of the problem is more focused on the classification and regression parts. So majority of the problem is more relate on the supervised learning, because the data nature is mostly like is on the way of prediction, classification, and maybe like clustering also. Just some, but it's not common like classification and regression. So because of that one, we can just give more emphasis on the classification and regression parts in the next presentation. Okay, for this one actually, this is the reference or the resources that I try to refer for the slides. So just some of the slides just give from these resources. So you can refer also these resources in order to understand more about the type of the machine learning algorithms and about, in general, the concept of machine learning.